Let's jump quickly into the next worksheet. I think I tried to add one more. I'm not sure if you'll have time. We can click streams. Let's see. Ah, there's something here, but that's okay. So sorry. So let me just. So basically, this is how I'm controlling the web page, right? And this is device agnostic, so it should work on different machines or devices. And so anyway, this is the YAML file I'm trying to update here. And you see, I didn't put the. So this is basically what controls my left menu, you're seeing. And okay, I just needed to paste that. And so how many of you know have used Git for version control? Okay, good. All right, good. So that's probably a good thing to get under your belt. You don't need to know too much Git. So okay, so anyway, that should hopefully update. So the Wikipedia clickstream example is quite cool. I'll probably do it in my community, in my academic shard, just because it'll take a minute and a half to evaluate it in the community edition. But that's from actually a Spark Summit talk from last year, which I thought was fabulous, right? So we'll try and maybe get there quickly. So this one is the power plant example. So this is our model regression pipeline we'll be doing. So let me go here, import URL. So I may kind of go fast on this, right? Because you can kind of read it pretty much. Okay, so this is a sort of standard example that people use. So I thought, let's do it. And all I've done is just taken this from a Databricks guide and sort of remarked it down a little bit with more explanation and some embeddings. So in this example is a little more sort of real world. So step one is now business understanding. Okay, so you have to understand what's the business problem. Step two is to load your data, explore, visualize. And once you've done that, later on, we'll do the other steps, which is data preparation, data modeling, tuning and evaluation. And we'll actually even do a deployment, like not hardcore production ready, but we will mimic a deployment scenario. So in the deployment scenario, what we're basically saying is measurements are streaming at you from the sensors of this power plant. And what you're providing as a service is the prediction. What will the power output of the machine be? Right? You do it before you actually see the power output. That's in current problems in Stockholm, data industry, actually all over the world. It's called what is it called? Industrial Revolution 4.0. Does anyone know about this? Have heard about this? Man, you guys are in the cave, it's academic cave. All right, actually, I didn't hear about this until recently, right? So, in fact, there's a lunch seminar. How many of you know of IIoT, Industrial Internet of Things? Okay, this is another, it's another buzzword. Maybe it'll die, but I probably doubt it. So basically, lots and lots of information is being gathered everywhere, right? Your refrigerators and so on and so forth. So everything can be plugged in, especially the new generation of toys, and they're just streaming data at you, basically by default. So a very, very lucrative problem is called predictive analytics, okay, or predictive maintenance. So what does that mean? That means, say, Electrolux or whatever, Fisher and Paykel, New Zealand, they want to be able to send a repairman to the right home, to the right machine before the machine breaks down, right? Or they may even want to, with very high probability, they know it's going to break down, this part is going to break down, they will actually, maybe message you and say, okay, we may just turn this off or slow it down remotely, and then they'll send someone out. This could be huge savings, right? Especially if it's within the warranty time. That's basically a jazzed up, a souped up version of what we're doing here. Okay, it's a little more involved. I don't want to poo-poo it. There's a lot more going on, but it's basically the same kind of idea. Okay, so this data set is from UC Irvine's machine learning repository, and it's for this particular power plant called Peking Power Plant. It's somewhere in the US. Yeah. So, okay, so this is basically the actual plant the data is from, but we're just getting the data that's been prepped for us from this repository. So here is the description. It's a combined cycle power plant data set. Here is a high level description. It's a multivariate data, so there's more than one variable. There's only 9,568 rows, instances. So each instance will be some time measurement, time specific measurement. Okay, so it's a 2014, and 48,000 people or downloads have been there. Right, so the task here is regression, and I guess in regression, the main thing is you are trying to model continuous data, right? So you're trying to predict something that's a continuous random variable, like the length of your hair or the amount of rain that falls in a funnel and collects in a capillary tube, and you look at the lower meniscus, that's a continuous random variable. Or the power plant, the power output that's measured in I don't know, volts or watts or whatever. The discrete thing you want to predict could be spam or not spam, like or good, bad, ugly, maybe finitely many discrete categories, and usually there is no notion of a distance between them, right? So when you do prediction for discrete tasks, the discrete variables, that this is called a classification problem in statistical machine learning. And when you're trying to do modeling and prediction for a continuous trait or a continuous feature, that's called regression. Okay, and these are all branches of statistical machine learning, because there's also logical learning and other schools of learning. Okay, statistical because we assume there is noise and use some probability. Okay. So let's just sort of dive into the data a bit more. So one good habit is to make sure that you have the required version of Spark. So this thing essentially, if you evaluate it, it'll just check and make sure we are running at least Spark 1.4 and above, because there were functions in this notebook from last year that required this version. And at a certain point, I'm changing it to require Spark 2.0 and above, so I just modify that. This is a bit hacky, but usually you don't want to change Spark versions in the same notebook. Okay, so let's load our data. This data should be already there. I hope it's there in Databricks datasets. Okay, and I'm giving you an explicit example of how to do this yourself for a different dataset. So now I have my RDD, and I'm just taking 5 and seeing what are the 5 lines. So it's just very nice. Looks like a tab separated variable file. So now I'm going to use Spark, which is the pre-made Spark session object for us. So that's why I just want to make sure it's Spark 2 point something. So you see here, and this is to be contrasted with what we did with just SQL context.read in the previous diamonds example, right? That's slightly different. So this is good in general for later versions. Okay, so I'm basically saying this is a CSV file. I peeked enough into it to know it's a tab delimited, so I put a tab character here, \d, and everything else is the same as before. Okay. And notice also, like when I put spark.read, I put CSV directly. I don't put the package, because in Spark 2.ish, the CSV reader was a Spark package before, but now it's integrated into core Spark. Okay, so then I sort of print the schema. And so AT was atmospheric temperature, atmospheric pressure, and relative humidity, and P is power output. I forgot what V is. Does anyone? Is it? Oh yeah, exhaust. Okay. Oh, exhaust vacuum. Right. Yeah. Sounds good. So let's just do an action and make sure everything is okay. So yeah, so we have what they said, the same number of rows. So this 2.1 is basically an alternative to how you would load a data set like this if it wasn't preloaded for you, which is important. So I've kind of have screenshots for this from before. So you basically can go to data table import. I believe it's slightly changed. So let's see. Tables, and yeah, you can drop file here. It's a bit more improved, so I don't want to get lost with this, but you should be able to drop a file here and then start asking it to infer schema and come up. So I've also put a link to the current Databricks guide on how to import. I think it's just this one. Okay, so just go there and play around. So you will basically get something close to this. You can import multiple files, and then you can try to have it preview, and then you can choose. If you don't like it to be double, you can click it and choose to be a different type, things like this. Okay, it's safe to just import everything as a string and do everything programmatically as well. Okay, so once your data is loaded, because this will go directly to the DBFS file store, so you don't need to worry about copying, like when we did wget from the driver and so on. Okay. So let's explore the data a little bit. So Apache Spark. So again, I said that .show is a good way, so I'm just asking 10 rows now. So these are my doubles. And we played with this already, so I'm just asking it to display pairwise scatter plot. Okay, so staring at this, it's quite clear there is quite a lot of linear relationship between some variables, because PE, remember, is our power output. This is what we're interested in predicting. So it's like your Y values, but it's the Y values against all the other ones. Relative humidity, atmospheric pressure, exhaust vacuum, and atmospheric temperature. Okay, so these are the pairwise thingamabobs. So you see there is a nice linear relationship, the negative slope, especially here, between AT, atmospheric temperature, and power output. So as atmospheric temperature goes up, power output goes down. And as atmospheric temperature goes down, the power output goes up. I don't know the physics. Maybe this plant is close to the northern part of the US, and maybe they're using power to heat. I have no idea. I don't want to make guesses. I used to know this data set, but I forgot. Okay, and this one's kind of linear-ish, but not really right. But right, so, but then this one's definitely like a whole mess, right? It's kind of a blob, and of course it just depends on the scale and the concentration and so on. And we remember we're only looking at the first 1,000 rows. So, so maybe maybe linear regression is good for this. Multivariate regression. And we'll see how it does well. And the nice thing about the pipeline is it's going to allow us in a very principled way to not only cross-validate a particular model against overfitting, okay, and not only do hyperparameter tuning for that particular family of models, but also allow models from different families like multivariate regression and say random forests or gradient boosted regression trees or deep learning, all of them fight with each other for best explanation in a fair way, right? So in a fair way, meaning in a mathematically, statistically justifiable way, right? All of that is built in the pipeline. So this is good. So you don't have to be, whatever, married to any model. You use the right model for the right job. Right. Okay, so here is just the same thing. I'm just asking what are the tables. Okay, I just have the same table. And this is the sort of Spark way of doing this. I can do spark.catalog list tables. This is the 2-point-ish way of doing it. And once again, I have SPLC table. I can also ask it to list my databases, and it's a Hive warehouse, the default database. Okay, so those are into this. The power plant data frame, I'm now doing this create or replace temp view. Remember, without this, I can't do SQL. So now I'm also using SQL context.table show because this will still work in Spark 2-point-ish. So now I have my PowerPoint table ready. Okay, it's a temporary table. The view is ready from the data frame. I can start doing SQL, right? So, and if you want to drop the table, because you may have lots of tables, like I don't really want this SPLC complete thingamabob, so I'm going to just go and remove that. Right. So now if I go back and say show tables, it should not show that table. I just, what did I do? Well, probably doing something anyway. Let me see, because that's external probably. So let's see. Yeah. So I think. Okay. Oh, because it's not temporary. Yeah. Thanks. Good. I just saw it's temporary. Okay, good. So anyway, yeah. So this is kind of useful because you just kind of get table pollution soon, especially the SQL guys. Like, so anyway, I'm gonna go and make sure I have my view to do the other stuff downstairs. Okay. So this is again SQL stuff. I probably won't evaluate all the cells. You can play around with it. I'm just sort of throwing these things at you. Later on, what we will do is we will call this entire notebook from a new notebook. So step 4, 5, and so on. So it's a good idea to make sure everything works in case there is no, I'm simply just telling you how you would explore the data, but you guys are scientists. So this is just a very nice thing, .describe. It gives you a summary of each variable. It gives you the count, mean, standard deviation, min, max. Right? Very, very quick to know what's the support of the points, what's the standard deviation, so so then we've already seen this. I've already blabbered to you each of those subplots in the pairwise scatter plot. I'm just giving it to you as a SQL expression here. So SQL expression just evaluates into this nice diagram. Okay. And if it doesn't, it'll be table by default, then you can just choose the scatter plot. So that's all this is. And I sort of said these two are more linear. This one's kind of a big mush. So it's hard to know what will happen. So we can try. We can try linear regression, multivariate linear regression, and decision trees, and maybe a forest of trees. And don't worry, I will explain in a sort of 10 minutes with some cartoons what the decision trees are next lecture. Okay, so I would like to jump to this clicky wiki click streams example because it's a bit more interesting. Okay, so we will do these steps next week. You could try it. So let's see if my okay. Yeah, so this looks okay. So you should be able to link address it here. Yeah, so try to import that from URL. So 010 Wikipedia clickstream. I believe some stuff isn't working this morning, so but most of it should. Let's see what happens. Okay, so let me attach. So this is a data set of 3.2 billion requests collected during the month of February 2015. And this is grouped by source and destination. So what does this mean? So this is the Wikipedia clickstreams, people clicking in Wikipedia. So every click has a source of where they came from and destination of where that click is taking them, right? That's it. So Google searches, you know, you know, are some of the sources. Though this is for the New York City page, I think, and from that page they went to New York, Manhattan, US, and so on. So these are other pages. Okay, so so this is basically the ordered pair for that page. So this one, I think I saw this the very morning of the day I made this notebook last year, so it still works. So I saw this really nice talk in Spark Summit East by Michael Armburst. Let's say, play this video, see what happens.
Thanks very much, Ali. I'm super excited to be here today to show all of you guys some of the really cool things we're all going to be able to do using Databricks Community. As you can see, we've got my email inbox up here,
Sure.
and I've received
Sorry.
join the base
to do
program.
this.
Everybody in the audience should be getting this throughout the day. And for those
He's
of you
really
who are watching this
amazing
on the
guy.
live stream, I encourage you to head over to databricks.com where you can sign up for the wait. We're going to be program as quickly as possible. So, all you have to do once you get this email is click to activate your account. It's going to take you through a sign up flow. And after that, it's going to drop you into your own personal copy of Databricks. This is your one-stop shop for creating Spark clusters, creating interactive notebooks, and learning about Spark in general. As already said, this is pre-populated with a whole bunch of educational content. So if you just head over to the workspace, you can start with the basics in the Databricks guide. This kind of gives you all of the details of using Databricks itself. How to create a Spark cluster, how to create a data frame, and create an interactive visualization with it.
So you guys know all this.
For those of you who are just getting started with Spark, if you go back to the workspace, you'll see that this is an award-winning, massive, open online course taught by Anthony Joseph out of Big Data with Apache Spark. It's YouTube videos that you can work through an active notebook.
There is a place that's interesting.
Inside of Databricks.
Oh.
And so once I've done that, I can actually go to any of the cells that contain code, and I can hit Shift-Enter the page. As an example, let's look at a visualization of what the data looks like for the New York City Wikipedia page.
So this notebook was tweeted by him that morning. I just grabbed the notebook from the tweet.
But another major source of traffic is the New York State Wikipedia page. And then, similarly, if we look at where people go once they're on this page, they click on other related topics like New York, Manhattan, United States. So now we understand this data set. Let's actually dive in and take a look at it. So you'll see the first line of code here actually load the data set from the Databricks file system. It's already pre-populated.
Okay, so let's just do it, right? So you can watch it later. Now, the annoying thing is YouTube automatically marks my video as someone else's copyrighted video when I embed the other video in my video. But I'm chasing it, so I might splice these out if they start doing weird things, because my content is unlicensed. If you understand it, it's yours. I'm not monetizing, but yeah. And also all the videos I showed you, they're YouTube licensed, and they're Creative Commons, non-commercial, non-modify, whatever. And as long as I don't monetize, everything is okay. So, which I'm getting paid to teach you guys, right? So that's why I'm already monetizing. So anyway, just to know, just a note. Okay, so this is basically what Michael, and he's the same guy that gave a talk on the finding James Bond cars in Beijing in this Spark Summit, right? Hopefully we can do that. That's kind of why I'm rushing a little bit. Start doing like deep learning prediction, because I don't know anything about it yet. So, okay. This is just some more background on where this data set is and wiki click streams and so on. So let's just make sure all this should work because we are on 2 point something. So then we're just loading the, this should work. Yeah, well, definitely the file is there. So let's just take 5 and see what so we have previous ID, current ID, previous title, current title, and the type. Now you can take 2, it's good. So the first line looks like a header. The second line is separated by comma. It contains data organized according to the header, right? Previous ID and current ID and so on. Okay, so here's the meaning of each column. So previous ID, if the referrer does not correspond to an article in the main namespace in English Wikipedia, this value will be empty, right? So otherwise it will contain a unique media wiki page ID. And current ID is the media wiki unique page ID of the article the client requested. Previous title is the result of mapping the referrer URL to the fixed set of values described below. Current title is the title of the article the client requested. And N is the number of occurrences of the referrer resource pair. It's very. So then type is, you can either be link if the referrer and request are both articles and the referrer links to the request. Okay. It could be red link if the referrer is an article and links to the request, but the request is not in the production. Another is if the referrer and request are both articles, but the referrer does not link to the request. Okay. So anyway, here's a bit more examples on how to interpret this if you really want to get to it, because you can grab new stuff from here. And some interesting papers are written about just mining this information. So okay, so let me see. So let's just so you can now load this. You should be able to load this. I'm just using SQL context to just make sure it works on older versions as well. This will take a while. Let's see how long it takes. Right. So I'm kind of giving you all the options now instead of doing each option. I'm just doing all the options by a key value pair. So I'm doing options map, header, true, that's key value, delimiter tab, and so on. Okay, so that seems to have done something. So now let's print the schema. Okay, that's good. Let's display some sample data using this display. So good. So we're nicely loading. Okay, so well, this is just showing the same thing. Now, reading from disk versus memory. So this is a 1.2 GB of clickstream file. It's currently on S3. right? This is Amazon's S3, which is under the hood below DBFS. So which means each time you scan through this, it's going to start again reading and the whole thing, right? So it's good to cache it, put it in our little distributed memory in this tiny machine. So that's okay because we have 6 gigs, right? So what I'm going to now do is count and cache, or cache and count. Right? So once I do this, which is now the actual job, I think this will take a bit of time probably. So but you've got a free thing, right? So on my academic shard, this is a little bit faster because I have a bit more here resources. We have six nodes, 6 worker nodes, and something like this. So let me try to maybe continue here. So it took me 39 seconds here. And so when I try this again, it's only 0.34 seconds, right? So it's quite quick. So let me know when one of your jobs finishes the cache count, just to get an idea of how long it takes. On
1.3 minutes.
Okay, that's not too bad.
44 seconds.
Oh, really? Okay, that's good. Okay, so then you can just continue where we are. So this is, what is it? It's 22 million, is it? 22 million clicks. Okay, now what are the top 10 articles? So these are things we can requested by just people coming this month, this year. So you can say display, click stream. Now I'm purely using data frame stuff. So I'm selecting, this is a kind of, I'm actually just putting the column name of the click stream and the column name as well as the data frame name here. And then I'm doing a group by current title and doing a sum, right? So now, and I'm ordering the sum in descending order and limiting to the top 10. So, okay, so for example, I don't need to put clickstream here. I can remove this, right? I can just use the column names directly. But when you have multiple data frames, you may want to call the data frame and the column. So 50 Shades of Grey is quite popular. I don't know. All right, you can get a lot of, so this is when ISIS was going a bit popular. It's Islamic ISIS is here. Stephen Hawking's. Okay, I don't know. Whatever this means, right? English Wikipedia. So then you can ask who sent the most traffic to Wikipedia in February 2015? Who were the top referrers to Wikipedia? So now I'm selecting the previous title and click streams. And n, the number. And then I'm grouping by previous title, summing, and ordering. So I think it'll be mostly other Google or, yeah. So Google, when people use Google a lot, that's basically the top figure. Wikipedia. So other Wikipedia is pretty high, so there's a lot of internal referencing in Wikipedia, right? Because okay, so what were the top 5 trending articles people from Twitter were looking up in Wikipedia? Kind of an interesting question, right? So you can do that. So now I'm basically selecting the current title, previous title, and the count, and then I'm filtering by the previous title being other Twitter, so references from Twitter. and I'm grouping by current title and summing and ordering. So the sum of n basically is, you know, is what will be the result when you just sum. If you just do sum and see what the data frame is, the column name will be sum of n. That's because it's summing the n. So then when you just do descending and limit to 5, you basically see this. So these are the most popular things from Twitter. Trending articles, people coming in from Twitter. So what percentage of page visits in Wikipedia are from other pages in Wikipedia itself? That's an interesting thing. So now I'm using, I'm using I'm doing a select expression of the sum n, and then I'm getting the first dot get long. So this basically will take this is just the long that represents all the clicks, because if you break it down and see line by line, this is just a trick to get the sum as a long, okay? So that I can do this division here, right? And because this is a double, this will be cast into doubles. This dividing double by long. Now, what is referrals? I'm taking click streams and I'm filtering it by previous ID that is not null, since I don't want the null ones. And then I'm selecting this expression, and once again, getting a long. This is kind of ugly notation. So this immediately gives me the percentage of page visits in Wikipedia that are from other pages in Wikipedia itself. Right? Okay. So here is the, we're just basically going to register this data frame so we can let the SQL loose on it. So this is now which Wikipedia pages have the most referrals to the Donald Trump page. I don't know if I did this or if Michael did it. I think I was obsessed with Trump for a while. It's kind of so boring and predictable now. Okay, so this is, basically you can see Ivanka Trump, this is his daughter, his wife. Daughter, yeah, sorry. Yeah, so Ivanka's, whatever, has quite a lot of leading in to Trump. Yeah. United States presidential, this was last year, so. Top referrals to all presidential candidate pages. So this is just, very nice in SQL. You can just say select previous title, current title, n, and then from the table clicks, which is now a view, we just do where current title is an element of this list, which is Donald Trump, Bernie Sanders, Hillary Clinton, Ted Cruz. And these are actually the page names in Wikipedia, so you can't put random strings. And then the previous ID is not null, and previous title is not the main page. Order by n, descending, limit to the top 20. So it's very nice in SQL. It's almost like English. So that tells us, Hillary Clinton, top referral is Bill Clinton, and Donald Trump, it's Ivanka Trump, and Hillary's second biggest one is presidential election, and so on. Sorry guys, I mean, Swedish really is not there yet to do this interesting in Swedish, but you can do this. Oh, by the way, it'll be really nice if we have like a random student of the hour. So if we, for example, take this, you just put some stuff, see what happens. Try and do something about Sweden, for example, right? This would be fairly straightforward exercise. That would be nice if you could share it with us. So maybe the first 5 minutes or something. it could be like a little warm up. You know, it doesn't have to be more than 5 minutes. It can be like a notebook, and you can share that notebook, right? Because I believe, isn't there a way to publish in Databricks Community Edition?
There's a public.
Yeah, publish. Yeah, you can just publish, and then you can tweet it to us. We can see it, as you're doing, right? That would be cool. So I think Yevgen might do something.
Yeah.
Russian characters.
Yes.
Because there's some Unicode problem. So anyway, that'll be nice if, I think Swedish will have the same issue, right? So we need to have a standard way of reading any characters. And using anything we've learned so far is a fair game. So this would be a fun example to play around. Okay, so load a visualization library. So this is, I am not sure. So I haven't had time to play with this. It kind of complains here. So I was going to do like a little visualization in D3. So we can use the package D3. So it's complaining about SQL context get or create. So I need to fix this for Spark 2 point something. Okay, so what this would show once it's fixed is that the outputs that we're getting, we can visualize in this sort of bubble plot with D3, because D3 is amazing. You can specify so much, you can play around, and so I think I need to do some work before this will work. This is very naive. The reason this is quite nice in Databricks is Databricks allows you to pump any HTML code into your cell, and it'll put the display of any HTML. So you can do quite a lot. Yeah. So 1 minute. So this is how you would convert your data to a Parquet file. So Parquet is this Google's columnar storage format. That's this Dremel paper. You can read about this. It's this famous paper, and it gives you for columnar data. Parquet is very efficient, so you can basically save the file as Parquet. So I think we have clickstream here. We can do. I don't know if I tried this. Yeah, I think I tried this. So I can do write mode is save mode overwrite, and I'm storing it in a directory. Datasets wiki clickstream. Okay, so now my data frame is just pumped into this Parquet file in a distributed storage. So that's just the file. So what you can do now is, well, let's just make sure I have something called clicks. Now I do SQL context.read.parquet and then put the path to the file. I'm rereading it back. Okay, so now I've just read back the file I wrote in Scala. And just making sure, okay, this is good. You can display if you like. Okay, so maybe let's display it just to be sure. And Parquet is actually quite good because once you've done all the hard work and you made the data frame and you write to Parquet, reading from Parquet is very quick into a data frame. So it's a nice intermediary point. But this is what I wanted to show you. So if you want to do a data frame in Python, because some of you guys are Python, and I've written like hundreds of lines of code in Python, actually not thousands. So I do Python a lot, but I'm just keeping Python out of you guys for now, right? Because we can turn Python loose like this. So now I'm saying ClickSpy is this. I just read it, right? Now my %pi ClickSpy is PySpark now. I have data frame in Python. So you can do all sorts of things in Python now, no problem. You can play around, and when you're moving around in the data frame land, it's fine to babble between Python, R, and Spark. So a lot of standard things, it's almost language agnostic because everything is done under the hood for you. We just want Scala because we may want to do something more delicate. And okay, so I think this is the video where he was showing all of this. It's just here again. And the guy, I think Yevgen wanted to do the R, so I just started this for you. %R, so you should be able to load it as a R, Spark R object and play there. Okay, so I'm done. So does anyone want to volunteer for, I think maybe Yevgen will try Wednesday to do something for a couple of minutes with word counts and some Russian book characters. Does anyone want to volunteer for Thursday next week to do some? This is Tilo's idea, and I think it's a good one, right? He says, well, we should try to make you guys feel like you can do stuff, right? Instead of me just blabbering. And so, it doesn't have to be anything fancy. And if you don't want to be on YouTube, you'll wear a little veil, parda. Anyway, let me know by email if you